All right, now off to a smooth start from here. So let's go to the next slide and discuss a little bit about, Chris had sort of mentioned what KubeVirt is, but in our own words, KubeVirt is a Kubernetes extension that allows running traditional VM workloads natively side by side with container workloads. In other words, virtual machines are running inside the Kubernetes cluster, as first-class citizens, and KubeVirt itself is also running inside of Kubernetes. So then the next thing is why? Why would you want to do this? And when you look at a traditional data center, okay, one back. We actually have, yeah, there, perfect. With a traditional data center where you're running both virtualized workloads and containers, it takes two management infrastructures. So that's twice the machines are allocated for various purposes. You've got the management infrastructure, you've got the logging, you've got everything, the storage, everything is not compatible. So you've got two of each. And it's just not a good way necessarily to use your resources. So what KubeVirt does on the next slide is we combine it into one. And this, of course, you've got just a single workload, or excuse me, the single stack for all your workloads this way. But that actually does something else too. And that is that if you're running them separately, you don't necessarily utilize them at the same load. It all depends on the business case for your situation. If you've got a heavy VM infrastructure, you might not have so much dedicated to containers. And so you might not be using one of the stacks quite as heavily as the other. When you combine them into one, then all the resources are dedicated to just whatever kind of workload in a more agnostic sort of way. And so with that, we not only converge the infrastructure, next slide, we also converge the workflow. You only need to learn as an admin one tool. That in this case is probably kubectl, just a standard Kubernetes management client. And so things look very familiar. On the left, we've got an example of what a pod might look like. On the right, we've got an example of what a virtual machine might look like. So our API ties very natively into, or what the native APIs for Kubernetes actually look like. So some of the use cases in this case, or that we want to talk about, we already mentioned mixed workload types where you're mixing virtual machines and pods side by side. Next slide. Reasons you might want to do that is if you're transitioning from more of a traditional virtual machine stack to containers, you need the ability to move your workloads across one by one. And so this would actually give you that path to do that. In some cases, that might never be possible. For instance, if you're running a microkernel where the application was the operating system, that has to be run in a VM. There's simply no way you can do that in a container because it just violates what a container is. Another great example is if you're going to go ahead and nest Kubernetes on Kubernetes. If you're familiar with the way that containers work, that's not really easy to do without a virtual shim in the middle because by nature, when you're containerizing something, all the namespaces have already been locked down for whatever your containerized workload is. So by running a virtual machine in the middle, it then emulates a full operating system and allows you the ability to recontainerize whatever workloads you're looking at. So that's a great example of where you might want to do it just because it's a modern workflow. Other examples, build pipelines for Windows applications. Again, Windows not being Linux is not something you can containerize directly because it's more than just a process, it's an entire machine. As well as traditional VM cases, your desktop and a cloud sort of approach. So talking a little bit about the architecture on the next slide. We have virtual machines and pods, as we've already mentioned. This is a great graphical example of what we're talking about. In a traditional application or in a container on the left, that's just a normal pod, like any other workload inside of Kubernetes. With KubeVirt, what we're doing is we're running KVM and QEMU inside of a container that we specially craft for that purpose. And then on the next slide, we also by doing this, we allow you to use one storage infrastructure, as we mentioned, the convergence of the infrastructure. Instead of a PVC being used for direct application data, we actually store the virtual machine's disk directly in the PVC. Networking is pretty cool. That is actually, in this case, we give the pod's network identity to the virtual machine. So it is a full-fledged first-class member of the pod network. So any traffic that you would route to your virtual machine or straight to a pod will end up on the virtual machine. So if that was port 80 for a web app, that'll work. Any other port that you would route, the same sort of workflow applies. And so if we look at the launch flow of how this plays out, as we had mentioned, we have a virtual machine instance is a YAML file. It's kind of a first-class citizen in this case because it's a custom resource, just like any other resource that Kubernetes has. When you post that to the cluster, next slide, it will actually go through the API server, which will validate the YAML and make sure that it's actually valid, so that you can't post something that's going to just not work. Once it's done that, it'll be passed to the Virt controller, which will create a pod which has basically no identity. It's like any other Virt launcher pod out there. And that will then be scheduled, because we're actually scheduling it directly, it will be scheduled by the kubelet as a pod on the system, because there's nothing special about it. It's just another pod. So we're taking advantage of all of Kubernetes scheduling that way. So whether that's anti-affinity or affinity for a node or for a different workload, all those can be applied directly to a virtual machine just the same way. So once we do that, the kubelet will spin up the VM pod, and then the Virt handler, we have one running on each node. Next slide. The Virt handler will actually notice that this pod exists and then tell it what its identity should be. Load the domain XML that it would actually use in QEMU. So, I mean, it's a little bit of a dance to make it work, but it's magic. And we'll show that to you in a demo, how that all just plays seamlessly. This is way down in the weeds, just kind of showing you how we pulled it off. But you wouldn't necessarily think about any one of these pieces, parts in your daily workflow. So in order to run KubeVirt, as we had mentioned, this is a plugin on the Kubernetes cluster. So this is basically, we use the operator pattern. We'll have a custom resource, or the KubeVirt operator YAML, and I will show that to you briefly in a minute. And we'll post a custom resource. The reason we need two here is because the KubeVirt operator actually deploys a pod, which is it's the beginning, it's the inception, if you will, of all of KubeVirt. But it needs to know where to put all the different daemon sets and services that we use, and which namespace, for instance, they need to go in. And so that's why the KubeVirt custom resource will be created separately. It's a namespaced resource. So when it's created, everything will end up in the right place that way. And so, that's a brief introduction to what KubeVirt is at a very technical level. But what we're here to talk about is KubeVirt on the Raspberry Pi. So this was kind of a fun adventure for us, because it's actually very bleeding edge. In ARM64 support, on the next slide, is not actually officially released by the KubeVirt project at this point, mainly because we need to be able to test it before we could really validate it and back it. And at this point, our daily CI runs aren't yet ARM capable. So we do have the ability to run ARM workloads, as we'll show you. However, because we're not testing it on a regular basis or on a per PR basis, we're not actually putting it as part of our releases yet. The work for that is being tracked in the issue 3558. I just put a little screenshot of it over on the right, just to give you an idea of where we are. We've actually got the basic functionality working, but there's some niceties that we might want to add. One thing in particular that we have found in our adventures here is that we are currently UEFI only. So if that's a new word to somebody, UEFI is like BIOS. It's the newer version of that, if you will, for a computer. But that's traditionally not what embedded systems out there use. Most of them will use U-boot of some nature. and they are not quite the same thing. So right now, when we're booting QEMU into UEFI mode, it can't boot a U-boot disk. And so I'm sure that's something that we'll be addressing at some point. We'll cross that bridge soon, hopefully. And with that, we'll jump over some demos. And so, Chris, I will turn the floor over to you, sir.
Yeah, sure. Thank you, Stu. Let me exit presentation. So we really try to make using KubeVirt as simple as possible. And for new Kubernetes users or new KubeVirt users, we want that experience to be under 5 minutes and as close to 0 as possible. So our website homepage offers several different ways to get started with KubeVirt. And I'm going to show you the Callegari method. KubeVirt is gracious to get some resources on Callegari. And this Callegari gives you a sandbox environment to tinker around with Kubernetes and KubeVirt. And we have several scenarios here to help users along. I'm going to show the first steps with KubeVirt, and this is installing KubeVirt and running a virtual machine. So I have my environment set up here, and as you can see, we have a Kubernetes environment and several nodes here. So one master, one node. It's very simple, and we're ready to install KubeVirt. We do a curl out to the GitHub API for our last release, which is 0.46. We do monthly releases, and that's just had a release last week. And we're going to install the operator. So we do a kube control get all. We'll see that installed. There we go. Let's do it -A. There's our virt operator. And then we'll install the custom resource. And not sure why I just got a forbidden 403. Uh-oh. Stu. Oh, cool.
The beauty of a live demo. I'll check it out.
Do we have a variable mismatch here? Nope. Maybe not time yet. Something is not kosher with
Well, it's crazy because I just hit the same URL and it works for me. So I really can't tell you what's up with that.
It's supposed to be so easy. Do you think I have to restart the environment? It's been sitting here for too long, and let's try seeing if we can do 45. So note that for the future, Stu, we have an issue with 46. Okay, since Katacoda runs in a virtualized environment. We do have to enable software emulation that enables virtual machine within virtual machine functionality. Okay, our Virt API is now launching. This will just take about 1 minute, and we'll just watch that. Here comes Virt controller.
So what it's doing right
And
now
Virt handler.
is it's actually the operator itself is deploying each of the pieces that makes up KubeVirt. As you can see, the Virt controller, Virt API, Virt handler are all being created. There's always 2 copies of the API and controller in this environment. That's for high availability or redundancy. There will be 1 Virt handler per node that we have in the system. And I believe he showed real quick that it was 1 infrastructure node and 1 worker node. So we should only get 1 Virt handler in this case.
Okay, and we now have all the components installed and running. We're ready to go. KubeVirt also ships with a Virt CTL client that helps us with the day-to-day virtual machine operations. So you can go ahead and gosh, another one. Goodness. I don't think we need a Virt control to proceed. I think we can just move along here. Okay, so now that everything is installed and running, we can apply a virtual machine YAML file. So I'm going to go ahead and apply that file, and let's take a look at what a VM YAML file looks like. Oops, sorry. Git. And so this is a very simple virtual machine. We call this a size small. We call it a test VM. It contains a container disk, and it's attached to via Virt IO. Container disk is our ephemeral disk. So any changes to this disk is going to disappear as the virtual machine reboots. We have a very small cloud init post deployment script, and our image comes in from our Quay repo. So it's very simple. If we do a kubectl git all, we'll see that virtual machine sitting here in a stopped phase and ready to be powered up. Okay, since virtctl is not able to be installed because of a tag issue, we're going to have to patch this one manually. Use Control Edit. Change that to true. Changes get applied, and we should now see him starting up. There he is. Okay, so, uh-oh, no vert control, no console. All right, well, now that it's running, we should be able to ping the IP. If we do a wide listing on that resource, we'll get the IP. We can ping it, and we can SSH to it. Stu, I forget that Ciro's password. You recall?
Go Cubs, go.
It was go what?
Go Cubs, go.
Got it. And we now have a virtual machine running within Kubernetes. Okay. Now on to the ARM section.
Sure. Shall I take over the screen then?
Yep, go ahead and take over.
All right. So that should hopefully be sharing. And so this is going to be a little bit repetitive to what Chris was just showing you, but the nice part is that we actually have the virtctl client here. So the first thing to do is list, let's see, I have infra. These are the different operators that I have installed above and beyond just a standard Minikube install, which is what I'm using here. So if for Minikube, that is only one node in this case. And so it is both the master, the control plane, and the worker in this particular case. So I have installed the KubeVirt CR and the KubeVirt operator, which is what Chris demonstrated. I won't make you sit through that again. It's already here. I also have installed CDI, and that's kind of a cool tool. If we look at the different resources I have here, I've got a data volume for serials here. So I'm just going to cat that, or actually go into it real quick. So this actually is something that's really key, because this is what you would use to get your own images into a cluster very easily. So in this case, we're pulling the same registry image. If this said actually HTTP, you could pull it directly from a URL. So in this case, we're going to pull.
Stu, sorry to interrupt, but
Yeah.
the messages that your screen's not shared.
Again, okay, let's see what we can do here. All right. And so I will try again, see if I can get, so this is just a window.
There we go.
Yep. Awesome, perfect. Okay, so we are, to recap a little bit here, this is this data volume Cirrus that I'm looking at. If this had HTTP, you could pull directly from a URL on a website. In this case, I'm pulling from a container registry, so this is what that format looks like. If I create that here, what that's going to do is actually create a pod called importer Cirrus. And if I quick check the logs of that, if I'm quick enough, it will actually be importing this data volume directly. So it pulls from the container in this case and takes and creates something called a persistent volume and a persistent volume claim, which are standard Kubernetes constructs that now exist. So if I look at that, I actually have I think Cirrus, the top one is the one we just created. That's, and here's the data volume that backs it as well. Ignore the netcat, that's there just in case everything goes crazy and we have no other way to demonstrate, but we should be good there. So to show what Chris had just shown with the, so if I take in here, if I set running to false and show if, so if I create it this way, when you create it with running false, you'll get a VM created but you see it says it stopped and it's not ready. Then this is the command that Chris was talking about in terms of being able to start that. Excuse me. So that will actually boot the VM up, and in 1 second, it'll catch up with me and be able to, so we actually are, what we're doing here is we're going through the API server and mirroring out what the text output from the virtual machine itself really is. So that's actually a pretty cool trick to be able to get at your virtual machine directly from outside, but we're actually not touching, we're not going through the service API at this point. We're going directly through the Kube API as opposed to a direct port. So in this case, I'm going to quit out of here for just a second because it's going to, it'll mess up the screen if I stayed there for too much longer. So with that starting up, in a minute that'll be running. I've already got one that's up, and that was this Nginx. So if we go in there real quick, what I wanted to show you here was I've got Nginx running. I've created just a cool little web page. It'll respond to anything you type in with this response.
Stu, I don't believe that this is an ARM64 virtual machine. I think you're going to have to validate that.
All right. So there we are with ARM64. Oh. Thank you for reminding me, Chris. And so I'm going to quit out of the console. I think it was flashed on screen real quick. It was Control Square Brace closed, and I'm back on the client machine outside of that console. And so at this point, then, if you look at and I never remember the syntax for this, so I'm going to, forgive me here, it's going to be expose. So this is what it ends up looking like. Kube control, expose, and this is the correct Virt launcher name for the Nginx. We're going to just create a quick node port against port 80 because that's where Nginx is running, as you can see from above. So if I create that, that should be in there. And there you have it. We have Nginx running. It was created 7 seconds ago. And then if I curl against that, let's see if I can remember the syntax here. And then we want this port. And that will then return KubeVirt demo. So what we're actually doing is going through the proper service channels at this point to route to port 80 on our virtual machine. And as we demonstrated here, that is, the VM is a first-class citizen. That was the pod network that we just went through. So I think that's pretty much what I was setting out to show, Chris. I will turn it back over to you. Hopefully I won't get kicked out when I stop my screen share here.
Okay, thank you. I just wanted to go over a slide or two to talk about our community. So we are a full community. We're not just a couple guys showing a thing off. We have a maintainer-led governance system with a contribution ladder. I'm in charge of onboarding new developers and getting them started. And this is not just C or Go contributors and developers. We need help with everything. So if you have marketing skills, computer graphics skills, if you want to be a tester or just a blog writer, feel free to join us. We need so much help here. Here's a list of our sub projects. We have a storage sub project, testing, network, the Virt control client UI, a new one that recently popped up. It was performance and scale for hyperscaling KubeVirt, running thousands of virtual machines, and documentation. Documentation is very important. Things change, documentation lags. We just need people to constantly pound on our documentation pages. Some community activities that we do, or we have a weekly community developer meeting that we run through Zoom. the performance and scale runs their own Zoom meeting. We have an annual contributor summit. We do face-to-face meetings around KubeCon, and all things open. Unfortunately, we're virtual this year. Really wish we would have been there in person. Some statistics on our GitHub. We have 580 people from 111 companies contributing to the project. 9 organizations have authorized us to advertise their presence. We run through the Pound virtualization channel on Slack. That's grown to over 1,000 members. KubeVirt has 656 forks, which increase daily. And we've had 58 monthly releases since the dawn of the project. We're currently a sandbox project with the CNCF. We're in progress to graduate to incubation. We have 2 maintainers outside of Red Hat that greatly assists that process of graduating to incubation. And I think I've already said that we held our project summit. We have a formal design process for new features, and all of this has led to a greatly improved responsiveness to PRs and issues over the last year. These typically get resolved now within a few days, where it was a week or 2 in the prior years. Who uses KubeVirt? Red Hat uses KubeVirt. SUSE, NVIDIA, StackPath. There's many more that we're seeking authorization to advertise. So hopefully we will see you around the project and you join our community. And here's some things that you can do to get involved. Visit our website, visit our GitHub, join our mailing list, and join our Slack channel. And if you like what you see, join us on the community call. I think that is all I have.
So I guess that means it's time for Q&A.
Let's see. I'm trying to get to the QA section. The more I click here, the worse my Zoom dashboard becomes. Oh, there it is.
So the question that just came in from Edward was, what's remaining to do with the ARM64 version of KubeVirt? So at this point, as I showed, it is working on a Raspberry Pi, just demonstrated that. We are testing, I think we've tested it on Ampere servers. So would imagine that there's not going to be anything special about any other kind of server out there. So I sort of tied in the next question that came in. But so as far as what we need to really make this a full-fledged member of the KubeVirt project is mainly CI, first up. We definitely need to make sure that it's validated as well as we are with the x86 64 builds. And then, of course, I had sort of alluded earlier, the U-boot issue. I'd like to do some digging and investigation there and see what more, what the art of the possible is. I don't know enough to know if QEMU has a mode for emulating U-boot, or if that, what the delta is there. So those would be the 2 big areas that I would see that we really need to look at. And of course, then as I had linked the issue. I don't have it in front of me. I think it was 3553. I think there's documentation left to be promulgated, but past that, I think that's really, you know, the main pieces. The basic feature does work and exists already. And so the next question was, has KubeVirt been tested on the AWS Graviton instances? Chris, didn't you do something similar to that during our testing for this demo?
I did not do it on AWS. I personally don't have a budget for it. So no.
You know what? Actually, yes. The answer is yes. We have tested it. We were doing some
not for this demo,
unrelated testing for that. We did use AWS services, and they do work.
Yeah.
Yes,
we've got several users running hyperscaled virtual machines, emulated virtual machines, because AWS, well, the common use is using AWS EC2s. We have many users deploying their virtual infrastructure into AWS EC2 and Google Compute, and they're doing some really neat things. Like we have one user running all their virtual machines, and the biggest virtual machine that AWS sells. And they're running the KubeVirt VMs within memory. And we want that user to contribute some documentation on what they have done.
That's cool. Okay, so those are the two questions that have come in so far. We'll give it a minute to see if anybody else has anything they can think of. So the question is, have we done any performance tests on the Pi? In the sense that, have we done formal benchmarking? I don't believe that's been done at this point. The thing I will note is that we are using hardware acceleration, because it is using the dev KVM device node on the Raspberry Pi 4. By the way, that's a good point. The Raspberry Pis we are using are Pi 4 8 gigs, and we put 1 terabyte SSDs on each of them. So as far as performance tests, nothing formal, but there's no reason to expect a detrimental experience there, because when you're using dev KVM, it's basically native speed, more or less. It's virtualization, not emulation, at least. Does that answer the question, or at least get in the right direction?
Stu, do you have your Raspberry Pi nearby to where you're sitting?
Yes, but it's plugged in underneath the monitor, so I can't actually. I could hold up the SSD. No, I can't quite.
Darn. My demo Raspberry Pi is downstairs in my garage, sitting about this high off the floor.
Yeah, I never did 3D print a case for this. It's just sitting there, a bare circuit on my desk for this time.
Yeah, we had a heat wave go through my area in the Pacific Northwest over the summer, so I had to move all my computing down to the garage and be close to that cool cement pad. So we kind of wanted this demo to be as like consumer oriented as possible, and so we our 2 Raspberry Pis are just, we both bought them off of Amazon, right? You got yours from Amazon, Stu?
Yes.
And so I think we got the same model, and then we have a WireGuard mesh in between them, and that's it. simple commodity hardware.
So we did get a question on the chat. And so that was, the question was, I got here a little late, so please excuse me if you've answered this already. How do you see KubeVirt fitting into the general virtualization landscape? Is the goal to be a full replacement for hypervisors or a more limited role? So I guess it's different. I mean, the goal of KubeVirt is to play well in a container environment. And so in that sense, we're tying into the orchestration engine that is Kubernetes or OpenShift, or we even run on K3s because we're quite cluster agnostic. So in that sense, we're not trying to replace the container ecosystem, but KubeVirt is a full virtual machine stack that can be managed, therefore, by containers as opposed to by a virtual machine management stack. So if that's what you're asking, then yes, the goal is to replace that because we're trying to converge into one infrastructure, which is managed through containers. Well, one more minute, and then I think our time will have to give up the floor to the next presentation. But if anybody has any last second questions.
I was eagerly looking at chat to see if he had a response. Oh, there he goes.
Perfect. Yep.
Yeah,
so that answers
definitely a convergence into one stack. There's virtual machines out there that are monolithic, but then there's virtual machines that will move alongside of a wrapper containerized microservice. I think that's going to be really the start of the move to the single stack, and then slowly the monolithic virtual machines will come too. So we have 1 minute left. I'm really glad that you guys all joined us. We're Project KubeVirt, and we hope to see. We hope that you join our project and look forward to working with you.